Good day, grade 11th. We are continuing with the general solution of trigonometric equations, and today I would like to focus on the combination of factorization and getting to the general solution. So the questions I'm using is from exercise 20 and 21 in the Via Africa textbook, chapter 6, page 185 and 186. So we are going to do number B, C, and then D from exercise 20 and number B from 21. So let's start off with the first one. This is exercise 20 number B, and it says the following. It says get the general solution, correct to one decimal digit. Okay. So the questions, it looks like this. 5 sine squared x equals 3 sine x times cos x. Now I know what many of you are thinking. You're most probably thinking, okay, I can just cancel out the sine x on both sides. But unfortunately we can't do that because there is this part of the solution that still applies, and by doing that we are falling away with one of our solutions that will actually work. So the best step to take is to factorize. But before we do that, let's just take everything to the one side of the equal to sign, and then you will clearly see how we will apply this. Okay, now let's factorize and take out the sine x, and then what remains is 5 sine x minus 3 cos x, and you would have left out this part of the solution if you just cancelled out. Okay, so we know now that sine x equals 0, or 5 sine x minus 3 cos x equals 0. So we're working with two different types of solutions from here. The sine x equals 0 is a straightforward one. We will focus on that one now. Let's first simplify the right hand side, and you can see different functions, same angle. So then we work towards tan. So 5 sine x equals 3 cos x. Now we divide by 5 cos x on both sides. And then on the left hand side we will end up with tan x. On the right hand side we will end up with 3 over 5. So now we're at a place to get to the reference angle, the cast diagram, everything like we always used to do it. So let's start with the left hand side. It's the easiest. So it's a 0, so we are applying it as if it is positive. Okay. So for our cast diagram is the first and the second quadrant, and let's get the reference angle. And you will know from our graph as well that the reference angle will be 0. It will be 0 degrees. Where sine x is 0 is at 0 degrees. Okay. We're working with the first and the second quadrants. Our first solution is x equals 0 plus k 360, k element of z. And this is our final answer. We can't simplify it further, so we don't have to leave a line open. Our second one would be x equals 180 minus 0 plus k 360, which we can just write as 180 plus k 360. So these are two solutions. For this part of the final solution, we still have to work with this one. So now to look at the right hand side. tan x equals 3 over 5. First things first, I'll cast the diagram and it's positive. So we're working the first and the third quadrant, but with the tan function, as you know, we always just have one single solution. So reference angle, second function tan of 3 divided by 5. So our reference angle is equal to 30,96, which will make this 31,0. That's our reference angle. That then means that x equals 31 plus k 180. There you have it, our three final solutions to this question. Okay, so number C, tan squared x plus tan x minus 2, and you will notice it's a trinomial, and we just need to factorize. So let's first factorize with our two brackets. It's a negative 2, so we'll definitely have a 2 and a 1. It's a positive in the middle, so this will be plus 2 and minus 1. And then we'll have tan x and tan x. Let's test it. Tan x times tan x is tan x squared minus tan x plus 2 tan x gives us the middle term minus 2. So it works out perfectly. And now we can write out. Okay, therefore tan x plus 2 equals 0, or tan x minus 1 equals 0. Tan x equals negative 2, tan x equals 1. So we've got two solutions to work with, and just to make things easier, I'm just going to draw a line there. Cast diagram. Again, I'm sticking to my simple steps, which helps you a lot with structure in solving these questions. It's a negative, so we know it's in the second quadrant or the fourth one, but because it's a tan function, we're only working in the first two quadrants. Now we need to get a reference angle. So you say shift tan of 2, and then you get your reference angle as 63,4 degrees. Okay, therefore x will be equal to 180 minus 63,4. Remember, we're working in the second quadrant, times k 180, and then that means that x equals 116,6 degrees plus k 180. Define your k always. Okay, now for the other side, it's positive. That means we're working in the first quadrant only. Our reference angle is 45 degrees. Therefore, x equals 45 plus k times 180. Now, because it was a tan function, we only ended up with two solutions. If this was a sine or a cos x, we would have ended up with 4 general solutions. So keep that in mind. Okay, let's move on to the next one. And that is number D. So let's look at number D. 2 sine squared x plus 3 sine x cos x equals 2 cos squared x. So again, you can clearly see it's a trinomial with a middle term of 3 sine x cos x. And let's simplify. Well, let's first structure it so that we can see what the factors are, the roots. 3 sine x cos x minus 2 cos squared x equals 0. Remember, if this is difficult for you to factorize, you can always, just for yourself in pencil, just put in sine x as place a y, and in cos x an m or some other unknown so you can work with it, but don't put in an x because there's already an x defined. So then this looks like a 2y squared plus 3y m minus 2m squared equals 0. And then you can see we've got a middle term of 3, we've got a 2 times 2 which will go to a 4 minus 1. So this will end up as 2 sine x minus cos x in the bracket times sine x plus 2 cos x. Let's test it before we go on. So this 2 sine x becomes a 2 sine squared x plus 4 sine x cos x minus 1 sine x cos x, which gives us 3 minus 2 cos squared x. That's perfect, it works out fine. Both brackets you will see will end up with different definitions, same angle, so we're working towards tan. So on the left hand side bracket will be 2 sine x minus cos x equals 0. Right hand side, sine x plus 2 cos x equals 0. The left hand side bracket, let's first finish this one. You will see we will end up with tan x equals a half because we divided by cos x and a 2 on both sides, which gave us that. And then over here, sine x equals a minus 2 cos x, so that will end up as a tan x equals negative 2. Let's start with the left hand side one. It's positive. So our cast diagram is in the first quadrant, and we get our reference angle as 26,565, so it's 6 degrees. It's only in the first quadrant, therefore x equals 26,6 plus k 180, k element of z. Okay, on the right hand side it's negative, so for our cast diagram we're only working in the second quadrant. Reference angle is second function for 2, it's 63,4 degrees, and this then means that x equals 180 minus 63,4 plus k 180, and that will give us 116,6 plus k 180. There you have your two general solutions. So the last one I chose specifically a more difficult one, or one that can be challenging, and you can see there it's not as that clear cut how we're going to work with it, but we do work with the same angle x, which makes things more simple, which is great. Okay, first of all we've got a cos x and a tan x. We need to keep in mind that tan x can be written as sin x over cos x, so I'm definitely going to do that first. That will be my first step. And then we take our basic approach that we always do, is we work with a lowest common denominator when we multiply that. In this case it's only cos x. So let's multiply with the cos x all the way through. Then you'll see on the left hand side term this would become 2 cos squared x plus 3 sine x equals 0. Okay, and then it's very easy to become stuck right here. Like, oh my goodness, what now? What can I do further? We have a middle term there. That is a strong indication that we are rather going to work with sine squared x if we can. Okay, and that's the only way to solve this one. So we are going to use our identity, square identity, and change the cos squared x into a 1 minus sine squared x. And that will help us solve this. Okay, now we're going to simplify. This is multiply in. This is 2 minus 2 sine squared x plus 3 sine x equals 0. Now I'm taking everything to the right hand side to get rid of that negative there, and then I'm putting it in the correct order as well. So 0 equals 2 sine squared x minus 3 sine x minus 2. And there we have our trinomial in a format that we can work with. So next step is factorization. So we need to get the roots. So we've got a prime number there, 2, so it's very easy, you know, it's going to be a 2 and a 1. And we've got another prime number, a 2, so it's also just going to be a 2 and a 1. We've got a negative term as a middle term, that's a 3, so that would suggest that this is a negative 2 and that's a plus 1 equals 0. Okay, let's test it. 2 sine x times sine x is 2 sine squared x minus 2 sine x plus sine x is minus 3 sine x minus 2. So that sorts it out. Let's split the brackets just to work with it. So this then means that 2 sine x plus 1 equals 0, or sine x minus 2 equals 0. Let's work with the left hand side first. So we take the 1 across, becomes a negative 1, then we divide by 2. So this will become sine x equals negative a half. The right hand side, it will become sine x equals 2. So the left hand side, we have a negative. So in our cast diagram, we know we are working in the third and fourth quadrants. And our reference angle, if you calculate it, you will see it's at 30 degrees. So our two expressions. First one is x equals 180 plus our reference angle plus k 360 k element of z. Remember to leave a space or two open and you say or x equals 360 minus our reference angle plus k times 360, and we simplify and we get this as 210 plus k 360, and we simplify this one as well, you get 330 plus k 360. There we have two of our general solutions. Let's see what happens on the other side. We have a sine x equals 2. So before we go on, I want to show you something on the sine graph before this gets confusing. Because if you're just going to work with a calculator and say second function sine of 2, you'll get an error. And this is why. The maximum value of a sine function is 1. The minimum value is -1. So it is impossible for a normal sine function like this one to have a value that sits on 2. So therefore you can draw a line through the equal to sign and you say not applicable. And that is it. This is the final solution.